Okay, this is the last bit that we're looking at. It's what's known as the double angle formula. So if you've got, say, sine of A, then what's the sine of, say, 2A, or the cos or the tan for that matter. Alright, so double angle formula, again, there's a few different ways of proving it. One of them is to use the previous formulae and make U equal V and substitute in and see what you end up with. Or you can do an internet search. But essentially, what we end up with is that sine 2u equals 2 sine u cos u. Cos 2u. There ends up being three different versions. Cos squared u minus sine squared u. It comes from when you use the addition angle formulae that we used before. That's what you get. But if you then incorporate the Pythagorean identity, where sine squared cos squared equals 1, there's two other versions. If you're substituting for sine squared, you get cos squared, 2 cos squared u take 1. If you substitute for cos squared, you get 1 minus 2 sine squared u. And then of course there's a tan one as well, and the tan of 2u is 2 tan u over 1 minus tan squared u. And they are what we call the double angle formula. Alright, so we can use those to find stuff. So let's have a look at a simple example. Alright, so given that tan 30 is root 3 on 3, find tan 60. Okay, so this is one of the exact values that you expected to know anyway, but just to go through the process, so 60 is 2 times 30. So what we're looking at is the tan of 2 times 30 degrees. Okay, and the tan double angle formula says that that's 2 times tan of u, which is 30, over 1 minus the tan of u, tan of 30, squared. So we've got 2 times root 3 on 3 over 1 minus root 3 on 3 squared is 2 root 3 on 3 over, which I'll do it up here because I'm running out of space, root 3 on 3 over 1 minus 3 on 9, which of course is 1/3. So on 2/3, turn upside down and multiply, so we've got some cancelling out. So it equals root 3. Okay, so here's another little proof. So you've got to prove sine 2 theta over 1 plus cos 2 theta equals tan theta. Now when we look at this, when you try and know where to start, you got to start the one that you can do the most with. The tan you can just change to sine on cos, and then that's kind of about it. The sine 2 theta and the cos 2 theta, we can do a lot with those. So our left hand side equals sine 2 theta is 2 sine theta cos theta 1 plus. Now because there's different versions, and we've got to figure out which version do we do we need to use for it? And the hint for that comes is that finally we're going to end up with tan. So we've got to end up with only cos on the bottom there. Okay, so we're going to have something that's going to cancel out with that cos on the top. So the version I'm going to use then is the one that has only cos in it, and that's 2 cos squared theta take 1. Alright, so 2 sine theta cos theta over. Right, when we remove those brackets, we got 1 here, and we're taking 1 there, so that's going to then end up with 2 cos squared theta. Get some more cancelling, because that can cancel. The cos squared can cancel with one of these coses, so we end up then with sine theta on cos theta, which equals tan theta, which equals the right hand side finished. Alright, so we can do that sort of stuff as well. Right, we can also do some simplifying if we like, and so here we've got cos squared theta on 2 minus sine squared theta on 2. So cos squared minus sine squared, and when we look up cos squared minus sine squared, we find that that is cos 2u. Where in this case, u is equal to theta over 2. So it's going to be cos 2 times theta over 2. And so it's the same as cos theta. So there's that when we have simplified. Okay, so we can also use them in ways like this, these double angle formulae. So we've got told what sine x is, and we're told what cos y is, and we've got to try and find, in this case, sine x. So this time, actually, again, some of the information is not going to be necessary. So I'm going to be excited when I copied that question. We don't need that. We're just going to work with this bit over here. So, how can we get sine x over 2 from one of these in some way or other? Alright, so the only thing that really we can work with is if we're working with the sine, it's 2 sine cos. Alright, so 2u, u, u. So if we said that it was sine u dividing angles by 2, or x, that's x over 2 cos x over 2. Which, while it's got the sine x over 2 in it, so all I've done there is I said, well, let's make this what we know, sine x. And so if we know that, if 2u equals x, then u equals x over 2. Alright, so it's got what we need in it here, but the problem is it's got this as well that we have no idea with. So we're going to have to do something with cos here. So cos 2u, and the version we're going to use is obviously the version that's going to have sine in it, and the version that's sine in it is 1 minus 2 sine squared u. And so if we let u equal x over 2, then we have cos x equals 1 minus 2 sine squared x over 2. And so that's got something in it that we need, that we can use, I should say, not that we can need. Cos x, we don't have that, but we do have sine x, and we do have the quadrant that it's in. So we do have sine x, and we do have the quadrants it's in. So using the Pythagorean, negative 7 on 25 squared plus cos squared x equals 1. So cos squared x equals 1 minus 49 on 625, which becomes 576 on 625, and square root that, cos x, so that's 24 on 25, plus or minus quadrant. We're in the between pi and 3 pi and 2, so that it is in the third quadrant, and in the third quadrant cos would be negative. Alright, so go back over to here then. So we've got negative 24 on 25 equals 1 minus 2 sine squared x over 2. Doing a bit of rearrangement stuff along here. So I'll do a few things at once. So we've got 24 on 25, taking another 1, dividing that by 2. Alright, so then dividing that by negative 2, I should have said, not by 2. What you then get is that 49 on 50 equals sine squared x on 2. So the sine of x on 2 equals plus or minus, whoops, don't need that one, square root of 49, which is 7, over square root of 50. Okay, 7 over the square root of 50. Okay, x over, yeah, so there we go. We need to then, of course, where am I? Here we are. Then, of course, we need to rationalise the denominator. So it's what we had, 50 plus or minus. So plus or minus 7 over the 50 is 25 2s, so 5 root 2. Rationalise our denominator, 7 root 2 on 10. Alright, and so then is our solution. So then we have to look at our angle restrictions, of course. Our angle restrictions on x had that x was in the third quadrant there, wasn't it? So we had pi was less than or equal to x is less than or equal to 3 pi on 2. That third quadrant, but we've now got x over 2, so pi on 2 is less than or equal to x over 2, which is less than or equal to 3 pi on 4. So that there is in the second quad, and the second quadrant sign is positive. So we cross all of that out. So sine x over 2 is 7 root 2 over 10. Alright, I hope that makes sense. If it doesn't, make sure you ask. It's just kind of pushing the edge of the envelope out a little bit. With you, we'll do some more of that sort of stuff over the coming year. Alright, so that's our last one. Revision next lesson, then test.